Okay, ladies and gentlemen, this is the final chapter of wave physics. Looking at this question here, which row shows the nature of light waves, sound waves, and X-rays here? So light waves are supposed to be transverse waves, sound waves are definitely longitudinal waves, and X-rays are also transverse wave. So C is the answer here. Visible light has a frequency approximately 5 times 10 to the power 14 Hz. This is the frequency. M and N are two other types of electromagnetic radiation, which I can assume that the velocity is going to be 3 times 10 to the power of 8 meters per second here. The frequency of M is about this here, and the frequency of N is about this here. Which type of radiation are M and N? So if they say that visible light has a frequency here, if you remember, the spectrum is ringgit Malaysia is very useless, no good, right? So it's going to be, if the visible light has a spectrum of times 10 to the power of 14 and going down the electromagnetic spectrum, the frequency is supposed to be increased, right? So if N is 5 times 10 to the power 15, it should be somewhere around here. If M is 5 times 10 to the power of 6, it should be somewhere around here. So this is M and this is N here. So which type of radiation are M and N? M could be either radio, micro, or infrared. So look at this, this is not possible. And N could be ultraviolet, X-ray, or gamma rays. So look at the answer here. B is the logical answer, right? So moving on, radiation from which part of the electromagnetic spectrum is used in a remote controller for a television? This one here is obviously going to be infrared waves lah. In fact, if you look at the controllers right on the side there, you can see that there's this small little dot that kind of emits infrared radiation to signal the television to change volume or channels here, right? After that, which part of the electromagnetic spectrum is used to send television signals from a satellite to Earth? If it's satellite involves, usually it will be microwaves because you'll have to transmit data in a further range, right? Which description applies to infrared radiation? Infrared radiation is definitely a transverse wave, and obviously it is a electromagnetic wave. So C is the answer here. Then describe the use of X-rays in a security application. Include a diagram here. If you're supposed to use X-rays in a security application, it can be no other than the X-ray checks of your baggage, right? If you're asked to draw a diagram, then you just need to label everything. You don't even need to have really good drawing, you know. You can say that this is your luggage here, you know. Yeah, just try to draw as nicely as possible. Then after that, inside the luggage you can see whatever is inside here, right? And after that there will be other luggages here. So you can just say that they can label it as luggage. Then this is the X-ray. Then after that you're supposed to describe what's the usage of it. You're going to say that airport security uses X-rays to check the insides of belongings of other passengers, right? So yeah, you can use this as your answer here, right? And after that, draw a straight line from each wave to the most appropriate speed. Radio waves in air is obviously going to be 3 times 10 to the power of 8 because it's an electromagnetic wave, right? Ultrasound in air will be slightly faster than sound. Or is it the same? Yeah, it's actually the same. Ultrasound in air will be the same speed as sound in air as well. So it's about 3 times 10. Sorry, it's about 300 meters per second here. Then X-rays are obviously an electromagnetic wave as well. So they will travel at 3 times 10 to the power of 8 meters per second as well. Alright, and after that, some of the components of an electromagnetic spectrum in order of decreasing wavelength are shown. So it's radio, micro, visible, ultra, and gamma ray. State the speed at which all electromagnetic waves travel. Obviously all of them will travel at 3 times 10 to the power of 8 meters per second here. State State which of the component of electromagnetic wave shown has the lowest frequency. High wavelength, it will have low frequency. So obviously this case here is going to be radio waves. It's going to be radio waves here, radio waves here. Then after that, state two components of the electromagnetic waves are not listed above. Name the components here. It's always going to be ringgit. Malaysia is very useless, no good, right? So you're missing the infrared and the X-ray here, right? The infrared radiation and also the X-rays here, X-ray. Okay? Then after that, the final part here. Oops. One application of microwaves is a microwave oven, which is used to cook food very quickly. Figure 7.1 shows the insides of a glass door of a microwave oven covered with a metal mesh. The metal mesh prevents the microwave from escaping by reflecting them back into the oven. So just one reason why it is sensible to prevent the microwaves from escaping. Obviously, microwave radiation is harmful for human beings, right? And you want to prevent it from escaping. So you can say something like, microwave radiation is harmful to humans if there is too much exposure. Okay. And state one further application of microwave other than microwave ovens here. Microwaves are very commonly used for telecommunication between satellites. So you could say something like satellite communication, or you could even say like mobile phone communication is also using the microwaves. Satellite communication, right? And moving on to the next one here. Not much questions. What do they want? Visible light, X-ray and microwaves are all component of an electromagnetic spectrum. Which statement about the waves is correct? In a wave, microwaves travel faster than visible light. No, they all travel at the same speed. In a vacuum, microwaves travel at the same speed as visible light and have a shorter wavelength. That is not true. Microwaves have a longer wavelength than the visible light. In a vacuum, X-rays travel faster. Definitely not true. In a vacuum, X-ray travels at the same speed and has a shorter wavelength. This is logical. So D is the answer here. Different waves travel through air. Which waves have the greatest difference in speed? Ultrasound and sound waves, they are the same. Ultrasound waves and ultraviolet, they are quite different. Ultraviolet waves and light waves, they are the same. Ultraviolet waves and radio are the same. This is the greatest difference here. This is about 300 meters per second, and this is about 3 times 10 to the power of 8 meters per second here. Then which piece of equipment is designed to produce a type of electromagnetic wave? Electric fire, maybe. Electrical generator, not possible. Electric motor, not possible. Then electromagnet is not possible as well. So the electric fire will be able to generate electromagnetic waves, which is in form of infrared radiation, right? And which statement about radio waves is correct? They are used in telecommunication, television, remote controllers, logical. They can be detected in the human eye, not logical. Travel longitudinal wave, not logical. They have the same speed in a vacuum as ultraviolet. Oh, this is more logical here. D is going to be the answer. I guess remote controls is more on the infrared radiation. So A is not acceptable here. All right, this is definitely correct. Then moving on to the next exercise here. The sun emits infrared radiation and light from the sun reaches Earth in 8 minutes. Which role gives the correct information about infrared radiation? Wavelength of infrared radiation is longer than visible light. Might be possible. Ringgit, Malaysia is very useless. No good here. Wavelength is the highest here. Wavelength is the shortest here. So infrared is somewhere around here. Visible light is somewhere around here. So the wavelength here is longer than the wavelength of light. Okay, possible. Longer wavelength than light here. Time taken to infrared reach Earth, it will be exactly 8 minutes as well. So not much to see here. Just A is the answer. Right? Which statement is not correct? the speed of long wavelength infrared radiation in a vacuum is greater than the short wavelength ultraviolet. No, they are all traveling at the same speed, right? Oh, then this is not correct already. Huh. Yeah, the speed of wave this is correct, this is correct, and then this is also correct. So this is the only one that is not correct, because by right they all travel at the same speed. Then different parts of the electromagnetic spectrum are used for different purposes. Below are 4 statements of a part of the electromagnetic spectrum. Statement number 1, infrareds are used in television remote controllers. True. Radio waves are used in transmitting television pictures from satellite to Earth. Possible. Ultraviolet waves are used for intruder alarms. This is definitely not true. X-rays are used for security checks. This is definitely true as well. Radio waves are used to transmit television from satellite to Earth. Actually, this won't be radio waves. This is supposed to be micro, because every time you're involving satellites, right, then obviously you need to use micro. So the answer here is going to be boy, guys. Right? Then represent the electromagnetic spectrum. Ringgit Malaysia is very useless, no good here. And state the radiation in each type of region A, B, C, D. Very straightforward. A will be infrared radiation, B will be ultraviolet UV rays, and then C is obviously X-rays, and G is obviously gamma rays. Right. Then after that, a dentist takes an X-ray photograph of a patient's teeth. Explain why it is safe for the patient to be close to the X-ray, but the dentist must stand far away from the source. Now, this is a very common question in your IGCSE. So you have to understand that as a patient, right, you are only exposed to X-rays for maybe a maximum of 10 seconds. But dentists cannot do that, because every patient will be 10 seconds. If you have 10 patients that day, it will be 100 seconds. And long exposure to X-ray radiation is definitely harmful to human beings. So you could say that, patients are only exposed to X-rays for a short period of time, whereby dentists will have to see many patients every day. Long exposure to X-ray radiation is harmful to human beings. Okay, this is how you're supposed to write this. Right, patients are exposed to X-rays for a short period of time, whereas dentists will have to see many patients every day. Long exposure to X-ray radiation is harmful to human beings. Okay, state with the reason why microwave ovens are designed only to work with the door closed. Obviously, microwave radiation is harmful as well, right? So you can only turn it on when it's closed, so that no radiation may escape the microwave oven, right? You can say something like, microwave radiation is harmful to human beings if exposure is too much. What did I say just now? It is state the reason why microwave radiation is harmful to human beings if exposure is too much. And obviously, microwaves are close door, with the door closed. Microwaves are microwaves will pass through something like that, or anything logical. Alright, then moving on to the final exercise here. An eclipse of the sun happens when the moon comes between the Earth and the Sun. Which statement is correct? Infrared radiation from Sun disappears before the visible light and ultra. Not true. All of them will disappear at the same time because all of them are moving at the same speed. Ultraviolet radiation from the Sun disappear before. Nope, not true. Visible light from the Sun disappear before. This is not true as well. Infrared radiation all disappear at the same moment. Obviously, donkey is going to be the answer lah. Which diagram shows the electromagnetic wave spectrum? Gamma ray, X-ray, ultraviolet, visible light, infrared, and microwaves, radio waves here. This is obviously going to have the greatest wavelength. So if I'm increasing, it's going to be the increasing wavelength here lah. Right. This is supposed to have the greatest frequency. Yeah? Then after that, an intruder alarm sensor detects a person is warmer than its surrounding. If you're talking about warmer here, obviously it's something to do with heat already, right? Which type of electromagnetic waves does the sensor detect? It's obviously going to be infrared radiation because infrared radiation is everything related to heat. Yeah. Then in table 6.1, show 5 different electromagnetic waves. In the blank column, write down number 1 to 5 to show the order of wavelength. Write 1 with the shortest wavelength and 5 with the longest wavelength. Yet again, ringgit Malaysia is very useless, no good, right? This one here has the greatest wavelength, this one here has the shortest wavelength. So it's 5 is going to be radio, there's no radio here. The next one will be micro. Oh, so this is 5 here. 5. Then after that, next one will be infrared radiation, which I do not have. So the next one is going to be visible light, 4. Then it's going to be ultraviolet, 3. Then it's going to be X-rays 2, and this is finally going to be 1 here. Right, the shortest wavelength is gamma, the longest wavelength is microwaves. And state the speed of radio waves in air. It is obviously going to be 3 times 10 to the power of 8 meters per second once again. Alright, and this is how you do all these questions here.